plus. So solving equations, we said if it's quadratic, like has an x squared in it, you either do one of two things. Factor it, or if you don't want to factor it, or if it's too hard to factor, or you can't factor it, you use the quadratic equation. So you need to know the quadratic equation. So those two methods are how you solve it. When we're just asked to factor something or simplify, then you're not solving, so you don't use a quadratic equation for that. That was like section 1.7, when we were just simplifying things. You use factoring and maybe stuff cancels. But when you're solving, and what is really important with quadratics when you're solving? What has to be on the other side of the equal sign?
Zero.
Always. So if there's a number there, what do you do with it?
Make it zero.
Make it zero first before you factor, use quadratic equation. That's really important. Okay. So let's say we have we'll just do a couple examples, and then we're going to add fractions and radicals in. So equals 0, that's good. It's a quadratic, so our options are either factor or use quadratic equation. If there's a term missing, you can still use the quadratic equation. What would be missing in this particular one? C, and that would be 0 if we wanted to use. But this factors really easily. What factors out of it? X. So x minus 3. Now, the 0 property says you take the first one equals 0, which is just 0, or the second one equals 0, which gives us 3. So our answers are 0 or 3. And what are those answers? What do they do? Right. They're like if you took these and plugged it in here, you would get 0 as the answer. So when there's an x squared, there's usually, not always, but usually two ways that equation can be 0. So we found two answers. What about this one? What about this one? B is 0 in this one? Difference of squares. Plus 4 minus 4, because the square root of 16 is 4. So then x plus 4 equals 0, or x minus 4 equals 0. What about this one? Here. So what about this one? It has to be equal to 0 before you start. So move everything over to one side. So this would be x squared. If we're going to move this 6x over, it becomes a minus. I just put it in between, so it would still go ABC. Now we can either factor or use quadratic equation for this. We'll try to factor it. So to factor, we need two numbers that multiply to give 9. 3 and 3, do those add to give 6? If they're both negative, because negative 3 times negative 3 gives positive 9. So 2 negatives. So what does this mean? Aren't these the same thing? How many answers are there? 1. You didn't need to do that. If they're both the same, you just write it once. Right? So you don't write it twice. And some people will write it twice because they're following a recipe in their head. They say, oh, got 2 brackets. And you're not even thinking about what you just wrote. You say x equals 3 or 3. Well, that doesn't make sense. It's just 3. Right? So write it once. And what does that mean? That means when we're going to draw these later, what does an x squared look like when we draw it? What's it called, that shape? A parabola. It's like a U shape. When we only have one answer, what it actually means for the graph is that it touches the x-axis just at the very tip, only in one spot. Where these other ones that have 2, it touches in 2 spots when we get 2 answers. When we get 1 answer, it touches in 1 spot. And what do you think if it gets no answers? So where would it be? Up high. Right? So that's the possibilities. Either it's below and it would cross in 2 places, touches in 1. And we're going to be graphing starting next week. This one? So it's not a difference of squares because it doesn't have the minus in it. So this one actually doesn't factor. But how would we show that? Say you forgot it doesn't factor. Hopefully you wouldn't write a difference of squares by mistake. Like if you took what do we do when we have something like this? How do you solve for x? What do you do to both sides? Square root. And then if you did the square root of both sides, what happens? A negative under the square root. It doesn't work. Okay? So this is not possible. Now this doesn't factor. If you tried the quadratic equation, what will happen? Yeah, you get a negative under the square root. So like a would be 1, b is 0, c is 4. If we filled this into the quadratic equation, minus b is minus 0, so just 0. 0 squared minus 4 times a times c. So we get that negative under the square root. Right? So no matter if you try to, it doesn't factor, because there's a plus, there's no way to factor it. If you try solving it like this, you get no solution. If you try the quadratic equation, you get no solution. When we go to draw this, it's a parabola shifted up 4. So you see it doesn't cross the x-axis. And when we're solving these, that's what we're finding is the roots or the numbers where it crosses the axis. So it actually is above, and that's why it has no answer. Yep.
So if you have like x squared plus anything equals 0, it's always going to be divisible?
As long as that's a number, yeah. You could have x squared plus an x, and that works because you can factor that. But if it's like x squared plus a number, it's no solution. If it's x squared minus a number, it has 2 solutions. It's a difference of squares. So this one just has no solution. You don't even need to do anything for it if you recognize that. Right? If you see that, okay, we've got x squared plus a number, that doesn't work. So if you recognize that right away, you just stop. You just say there's no solution here. But if I'm showing you, if you kind of forget that or don't notice it right away, hopefully you won't factor it by accident, thinking it's the difference of squares, and then get 2 answers that don't actually work. Did you have a question, or you're good?
You answered it.
Okay, cool. Okay, so x squared minus 6x minus 9 equals 0. What would we do? Factor. So 2 numbers that multiply to give 9. 3 and 3. And how do we put the signs in to add to give a minus 6? They don't both have to be minus. But what's the problem? You always have to check. Like, put your minuses in, but then you check. Does minus 3 times minus 3 give me a minus 9? No. So that doesn't work. Then you say what? Is there another option? Was there 2 other numbers that multiply to give 9? 9 and 1, but that won't give me a 6. Right? No matter where I put the signs, I can't get a 6 with that. So what does it mean when this happens? quadratic equation. It doesn't mean there's no solution. It just means we can't factor it that way. There might be a solution or there might not, but we put in the quadratic equation to see. So A would be 1, B is -6, and C is -9. So here it doesn't factor. So try quadratic equation. And I said before, even if it does factor and maybe you didn't notice, or you know, if this was 24, what multiplies to give 24? 1 and 24, 2 and 12, 3 and 8, 6 and 4. There's lots of options, but if you missed one of them and that was the right one, if you jump to the quadratic equation, you'll still get the right answers. So it doesn't matter if you missed factoring, even if it could, you can still use the quadratic equation. -6 squared is 36. So we get 6 plus or minus 36. Minus and a minus is a plus. 9 times 4. Okay, this is actually a very good answer. A good question. So that equals 72, but I'm not writing it yet because I'm going to show you how to simplify it. Do we know the square root of 36? Yes. But there's something we can't do here that you might want to do by mistake, and that is, so I'm going to write bad. If you said 36 plus 36, what would be the wrong way to do this? Right, if you say, oh, I can take the square root of both of those, so do it. 6 plus 6, this is not equal to 6 plus 6. Okay, square root of 72 is not 6 plus 6. 6 plus 6 is what? 12. Square root of 144 is 12, not the square root of 72. Do you understand what I'm saying? Yeah, you can't do that. You can't take the square root of both pieces, even if it looks like it would be nice to do that. Okay, this is not equal to 12, right? 144 is equal to 12, right? So be careful of that. How do we simplify radicals? So this is 72 if we want, but or we could say it's 36 times 2. Do you agree with that? Now they're multiplied. So when they're added, you can't break it up and take the square root of each piece, but when they're multiplied, you can. That was a rule when we did radicals. So what could we put here? This is square root of 36 times square root of 2. Square root of 36 is 6. Root 2 we can't simplify anymore, so it's just root 2. Now how do we simplify these? Do you remember or no? So that 2 has to apply to both. So you can put the 2 under the 6 and then the 2 under the 6 root 2. So this would be 6. Put the 2 under each. So this will be 3 plus or minus 3 root 2. So even though we don't know the answer to this question, now if you didn't simplify the 72 and left it as root 72, you're not really going to lose marks. Okay? But when we go to graph these things and you have to guess what it's equal to, it might be easier to guess like this, or it might be easier to guess leaving it as a 72. So what I'm saying is, or up here, let's say, or you could say, and just leave it like that and not notice that it simplifies more, okay? So it would be okay to do that. They're both the same answer, just one is simplified more than the other. And that's the answer, even though, I mean, if you put it in a calculator, you could get a decimal. It just doesn't work nice, right? So that's why it wouldn't factor. Okay, so let's do a couple with fractions. So we're going to simplify the fraction, and then it'll come down to being a quadratic that we solve either by factoring or using quadratic equation. So let's start a new page. I just said that's the same answer, just not simplified. Hopefully you already wrote that down anyway. Okay, so fractions. Okay, so the difference here and what we did in the section before was we were simplifying fractions, but there was no equal sign. So we were just simplifying an expression. Now we need to use those sort of techniques, but rearrange it and solve. So when we have fractions and an equal sign, that's when we can cross multiply. When we have fractions and an equal sign. You never cross multiply unless you've got an equal sign. So there is an equal sign. So that's how you get rid of the fraction. We're going to cross multiply. So what does that look like? Take this x and where does it go? To the top of the other side. This 2, up. So what we have is x times x plus 3 equals minus 1 times 2. And then there's no fraction. That's your whole goal, is get a fraction on each side so you can cross multiply. Now, where's the complication going to come in? If you have to do common denominator first, and then so that you have one fraction on each side. So that's where it's harder. Otherwise, it's just easy. So how do we solve this? We need everything to be on one side equals 0, and then we either factor or use quadratic equation. So let's multiply this out. Minus 1 times 2 is minus 2. And there it is. So this fraction comes down to finding the answers to this. They'll work in the original. Okay. Now, does this factor? If it does, good. If it doesn't, quadratic equation. Two numbers that multiply to give 2. 2 and 1. We want them to add to give 3, so they both be positive, and they multiply to give 2, so that's it. Here's 2 answers. Now, if we were to check our work, we'll check them because it'll give you practice with fractions. If we are to check, so check one at a time, so say -2. And you take your original question, always the original, not after you cross multiplied. Because if you cross multiplied wrong, then you're actually checking your answer in an equation that's not the question. Do you understand what I'm saying? If you screwed up in that first step, and then you check your answer in that first step, then it might work out right, but your answer's wrong. So you always go back to the very original question. So we're going to plug in a -2 everywhere there's an x. Don't cross multiply to check. Check each side and see if they're equal. So here we've got -2 plus 3 is 1 over 2. Minus and a minus is a plus, 1 over 2. And then if we wanted to check the other answer, -1, same thing. Take your question. Put the -1 in. here we get minus 1 plus 3 is 2 over 2, which is 1. And a minus 1 over minus 1 is a 1. So that works. Okay, so then this is where you have to do extra steps. You can't just cross multiply. The only time you can cross multiply is when there's an equal sign and only one term or one fraction on each side. Right now we've got two fractions on the left, so we need to combine those first, and then we can cross multiply. So how do we combine them? Common denominator. So we're going to multiply, nothing simplifies here, so we're going to multiply this one by x minus 2 on top and bottom. And the second one by x plus 1 on top and bottom. Whoops. We can just leave the other side alone. It doesn't need to be a fraction. So now we've got the same denominator. We can write it as one big fraction. And what goes on top? Everything here plus everything there. So 1 times x minus 2 plus x times x plus 1. Now, what did I say when you get to this point? When we're simplifying, leave the bottom factored, because it might cancel something out after and you don't want to refactor it. The top, work it out. So 1 times that is just x minus 2 plus x squared plus x. So on top we've got an x squared, x plus x, 2x minus 2. It looks like it might factor and cancel, does it? It looks like it might, and what you might do is just try it. Like if we were going to factor the top, two numbers that multiply to give 2, 2 and 1, we want them to add to give 2. Well, they add to give 3 or subtract to give 1, so it actually doesn't work. But it looked close, which would be nice if it did, because then you end up with an easier question. All right, what do we do? Yeah?
Won't the common denominator end up being x squared minus 2?
If you were to multiply these, you mean?
Yeah.
Yeah, if you actually multiply them, you get x squared minus 2x plus x minus 2. You have to FOIL out when you multiply. Does that answer your question?
Yeah, I was
Yep.
sure I got the right knowledge. If I did multiply them together, I was going to try getting the right x squared minus 2.
Yeah. Okay, so now what? Now we have one fraction on each side, so what do we do? Cross multiply. Like this is like over 1, or you just don't need to bring anything up. So if we cross multiply, you're taking this whole bottom and moving it up to the top. And now we do have to multiply that all out, bring everything to one side, and then either factor or use quadratic equation. So I'll say that again. You can't solve it like this. This is nothing. It needs to be a quadratic, everything simplified on one side that you can find the ABC in case you need to use a quadratic equation. Part of it being factored doesn't do anything for you because it needs to be all together with a 0 on the other side. So you have to multiply it all out, bring everything to one side. So here, if we were multiplying out these brackets, and then there's a 2 in front, So here we get x squared minus 2x plus x minus 2. This is x squared minus x minus 2. Now what? Put the 2 in. Because you want no brackets. You want everything individual so you can move it all to one side. Now move it all to one side. You can move it all to the left, which is what I normally do. But what if we brought it all to the right? Why would that be better? If I move them to the left, what's the x squared term going to look like? Right. So it doesn't matter which side, as long as one side equals 0. You can keep moving them to the left if you want, but I just noticed these terms. If that's a 2x and I bring this one over, it's going to be minus x squared, which will be positive. It's better for the x squared to be positive. If it's not positive, what do we do? Let's bring it over to be negative and just do it the way I normally would. Okay? So I can show you what to do if you get a negative x squared. So x squared plus 2x minus 2 minus 2x squared plus 2x plus 4. Change all the signs, bring everything over to the other side. So we have equals 0. Once everything's on one side, collect the like terms. So there's an x squared minus 2x squared, 2x plus 2x, minus 2 plus 4. We cannot factor that like that. Do you remember what I said if there's ever a negative in front of the x squared, what you do? Divide everything by -1, or, which is the same as changing all the signs, or move everything to the other side. You never want a minus in front of the x squared. Okay, so we never want a negative x squared. You could use the quadratic equation, but you cannot factor when it's a negative x squared. There's no way to do that. So to change the signs, like you could factor out a negative, that changes all the signs. There's a negative in front, which you could divide both sides by -1. If there's an equal sign, it cancels, like it's gone, but you could leave it there if you wanted to. But we could divide both sides by -1. Okay, but I said the other options is change all the sides, like move them all over to the other side equals 0, so that the x squared is positive. If there's an equal sign, you can just change all the signs in it always, right across. So that's another option. So you can just change all the signs. That's what normally I would do. Change all signs is allowed if there is an equal sign. Okay? Because you see what I had right here and what I have right here, what's different about them? Just the signs are all changed. And you're allowed to do that as long as there's an equal sign. Okay. So, anyway, let's factor. Does this factor? Two numbers that multiply to give 2. 2 and 1. Do they add to give 4 or subtract to give 4? No. So we need to use a quadratic equation. So A is 1, B -4, C -2. Something else I notice sometimes is that you guys forget to put the x equals when you write the quadratic equation. Don't just write that part. You have to say x equals. That's what you're finding is the two x values, so it has to say x equals and then your quadratic equation. What if there was, I keep doing it with just x's in here, but any letter would be fine. What if they were m's in the equation? What would we put different when we wrote the quadratic equation? M equals. So be careful of that. Sometimes in books they'll have different letters, or if you're using, like doing a word problem and it comes down to this and you've got v's in your equation, then your answers are not x's anymore, they're v's equal, right? So minus b squared is 16. So 16 plus 8. Uh, 24. Okay. And I'll simplify this one again. I'll show you how to simplify it. Although the answers like this are okay, does square root of 24 simplify any? (24) is what? 12 times 2. Does 12 or 2 take the square root? No. 6 and 4. Does 6 or 4 have a square root? Yeah, the 4. So this is 6 times 4. So you can do square root of 6 and square root of 4. Square root of 6 doesn't work, but the 4 does. So this is 2 root 6. And you put the 2 with both pieces. Now where did they go? How did I get from here to here? Yeah, 4 over 2 is 2, and these 2's cancel, because they're multiplied, so you can cancel. And this goes into that twice. So there's your two answers, are what? 2 plus root 6 or 2 minus root 6. You don't really want to check these when you get some irrational number like this. I mean, you don't want to plug that in. That's way too much work. You'd probably make more likely to make a mistake checking it than you would have been to find the numbers, right? Because you'd have to FOIL something with a radical in it. And yeah, it would be longer than doing the actual question to check it. So I wouldn't advise you check it. But if you were home and wanted to see if you were doing it right, you weren't sure, how could you check it quickly? Get a calculator out, put this number into the calculator, get a decimal, and plug the decimal into the original, and just see if both sides work. If you had a calculator, that would be a quick way. But like in class, on a test, like to check that would just take way longer than you need. Okay, so that's, it's longer, fraction, for sure. Let's do a radical. Yeah, it's long, and you probably forget where we even started, because that was 2 pages long. But what that question was, it had a common denominator. So you did the common denominator first, then cross multiply. Okay? Then bring everything to one side and factor. It's always the same. It's just sometimes it'll be nice and work nice and things will cancel, and sometimes it won't and it'll be long like that one. So let's do a radical one. I'll show you the difference. So radicals. Let's just do one that works nice first, and then I'll show you the harder ones. So this one is nice, and the reason it's nice is because there's just one term on each side of the equal sign. There's a radical on one side and a number on the other side. Just one thing on each side. What do you do to each side? Not square root, the square. Don't forget to square both sides. People did miss that on the test. And then your whole answer's wrong. I'll finish marking them this weekend. So when we square a square root, like on the test, people just left this side as 5 instead of 25, and then the whole answer's wrong. And then they checked it and thought it was right. Twice. And I've only marked about 6 of them so far, and 2 people did the exact same thing. Got the wrong answer, and then checked it and said, oh, it's right. But the check was wrong. So yeah, be careful that you don't do that. It's sad when you do your check wrong and you think it's right. So what's 9 minus 25? Right. So what I did, I squared both sides, move everything to the other side. Whenever there's an x squared, you need it equal 0, and then you either factor or use quadratic equation. Does this one factor? Yes. Difference of squares. Now, what's the rule with radicals? No matter what, you have to check your answer. Because once we squared both sides and we're solving this, it might give us something that's negative. We always have to go back and check our answer. These ones are both going to work. I know already that they're going to work. So if we check minus 4, that's the iffy one really. What's minus 4 squared? 16. The other one's going to work because it's positive 4. You're going to get the same thing. Do you see it? Yep.
Can you just see that they both work because it's x squared? So
Exactly. I wouldn't even check the other one, but yeah. Because whether you, and that's why I said I knew already I didn't need to check this one, because if you look at the original question, the only place there's an x is a squared, it's going to be positive. Yeah. But if you didn't notice that, you plug them both in. The other one will work as well.
So would you need to check both sides and all that?
Not really. I mean, I would know that, but that doesn't happen much of the time. This is like a simplified question that you probably would never get. But I just want to remind you how to do radicals, square both sides. So what's actually going to happen is like this one. Now, this question is crazy long. I wonder if I have a shorter one. I don't know what the answers are to this one, but let's try this one. It looks a little shorter. Okay, so what's actually going to happen in a question is you've got 3 terms instead of 2. So here we've got 2 terms. And everything we did so far in radicals always had 2 terms. We put one on each side and squared it. Here's the problem. This has 3. We still can square both sides, but the problem is now we've got 2 terms on this side and it won't make the root disappear. Okay. So this is a good example. What you want to do, your first step is to isolate the hardest radical. Okay, so I'm going to write that down. Which one do you think is the hardest radical? Yeah, the one with the bigger numbers or more terms under it. This one's a little easier, but it doesn't, I mean, if they both look about the same, it doesn't really matter, but it's less work if you can figure out which one is the harder one or the bigger one. So I'm going to say isolate the hardest radical. What does isolate mean? Get it on one side by itself. So if I was going to do this, I would rearrange it first, although not absolutely necessary. I would put the harder one by itself and move the one over. Okay. You're going to end up with the same answer if you start with the easier one, but I think leaving the easier one till later is probably easier. So here we've got it. We've isolated it. The difference between this and the fractions is that with the fractions you could do a common denominator, make it into one thing, and then cross multiply. You can't do that with radicals. You can't make these into one radical without making it into a fraction and making it more complicated. So what we do now is isolate it and then square both sides. So I'm going to write that in a new step. this does cancel because it's a square root and a squared, but this one doesn't. Because you can't square just both things in a bracket when there's a plus sign. What do you have to do? Foil. You have to write the bracket out twice and foil it, and there's still going to be a root in it. So this side needs to be expanded using foil. So you would write it out twice because it's squared, and then foil it out. So it actually has four parts, not just squaring each. And this happens with every question that has two radicals in it. And some third one. It might have three radicals, which you'd have to square both sides 3 times to get rid of all the radicals. We don't want to do that. So this is just 2. So that side's okay. What's root 4x times root 4x? Just 4x. Root 4x times root 4x is 4x. They cancel. Now root 4x times minus 1. Minus root 4x. The inside, minus 1 times root 4x. And the last term, minus 1 times minus 1 plus 1. What's this? I know it looks confusing, but like if I had minus x, what's that equal to? Minus 2x. So what's this one equal to? Is minus 2, instead of x, minus 2, root 4x. Plus 1. Okay. We'll do another one of these at next class, at the start of class. But I'm not going to do a whole bunch. You really just need to try them. Follow the steps. There's a couple on the homework. And see if you can duplicate it, right? So watching me do it is all well and good. When you try it on your own, that's when you discover that it's not so easy as when you watch me do it. Does anyone find that? Watching me do it, you say, oh yeah, I knew the steps, I could answer, I follow along. Then you go to do it on your own and you have no idea. Right? That's why you have to practice a lot on your own. Ideas, what we would do at this point. We want to, there's still a radical in it, so we want to isolate that radical. That means move that to one side and everything else to the other side. So we want to then isolate this one. So let's move it over to root 4x and everything else to the other side. Change all the signs. 4x minus 3x. Okay. Now this we've already solved, like similar questions to this, because now what we have is a radical on one side and everything else. We square both sides. You still have another foil in there, but we will have no more radical. So the radical's not quite isolated. What could we do? Divide by 2, but is that going to give us fractions? Yeah, so let's not do that, okay? We're going to square both sides just as it is. Here, remember to square the 2 as well as the radical. So what would we have? 2 squared and root 4x squared. So remember to square both. Squaring this involves FOIL again. These questions are significantly longer if you have a quadratic in it. Okay, so 2 squared is 4. Root 4x squared is 4x. And then multiply this out. can trust me that I did that properly, just write it down. We're running out of time, so I want to get to the actual factoring. 4 times 4x, 16x. All right, so here it is. We started with two radicals. We isolated one, squared both sides using FOIL. Isolate the second radical, square both sides, still again use FOIL, but now we've got none. If there had been a third radical, we would then have to isolate the third radical, square both sides, and then they'd be gone. Yeah, so we won't do more than two, but we could in the practice have 3. So what do we do at this point? Which side should we move them all to make it equal to 0? Yeah, let's move it to the right because the x squared is already positive. So if we move that 16x over here, the 0 doesn't matter what side the 0 is on. Does this factor? 9 and 1, it does, good. And we don't need to use quadratic and we can end class. So x equals 9 or x equals 1. I'm just going to write check answer. Let me look at the original. I'll tell you if they both work. Yeah, they'll both work. So those are the two answers, okay? But you can check them on your own. They will both work. So what's the homework? 1.7. This is 1.8, which we're actually done, but that'll be on next week's homework. But if you're eager and have lots of time, you could start that, right? Because we are done that section.